Understanding recursion. Recursion is a technique where a function calls itself directly or indirectly to solve a problem. It's like breaking down a problem into smaller, similar subproblems until you reach a base case that can be solved directly. Key components of recursion. A base case, the simplest form of the problem that can be solved without further recursion. A recursive case, the part of the function that breaks down the problem into smaller subproblems and calls itself recursively. Example, factorial. Python. Def factorial, n. If n equals 0, hashtag base case, factorial of 0 is 1. Return 1. Else, hashtag recursive case, factorial of n is n asterisk factorial, n1. Return n asterisk factorial, n1. Result equals factorial, 5. Print, result, hashtag output, 120. How it works. 1. The factorial, 5, is called. 2. Since n is not 0, the recursive case is executed. 3. Factorial, 4, is called. 4. This process continues until factorial, 0, is reached. 5. The base case returns 1. 6. The results are multiplied back up the call stack to calculate the final factorial. Advantages of recursion. I can make code more elegant and concise for certain problems. I often reflects the problem's natural structure. It can be easier to understand than iterative solutions for some problems. Disadvantages of recursion. Can be less efficient than iterative solutions due to function call overhead. Can lead to stack overflow errors for large inputs if not handled carefully. Can be harder to debug than iterative solutions. Common recursive problems. A factorial. A Fibonacci sequence. Tower of Hanoi. A merge sort. Quicksort. Binary search. Tail recursion. A special case of recursion where the recursive call is the last operation performed by the function. Some compilers can optimize tail recursion into iterative code, improving performance. When to use recursion. Problems that can be naturally divided into smaller, similar subproblems. Problems where the solution depends on the solution of smaller instances of the same problem. Problems where the recursive solution is simpler to understand than the iterative one. Cautions. Always define a base case to prevent infinite recursion. Be aware of potential stack overflow issues for large inputs. Consider the efficiency of recursion compared to iteration. In conclusion, recursion is a powerful tool in Python for solving certain problems. Understanding its core concepts and when to use it effectively can lead to elegant and efficient code.